So hi everyone, I'm Professor Stali, Carl Stali. Carl Stali is what most people call me, is just my last name. Thank you for coming out tonight. This seminar kind of came together quickly and was in response in part to student interest and student expression of wanting to have more opportunities to talk about professionalization topics, and one of those is Git, and to a lesser degree, well, the student request was also for GitHub. We are going to talk about GitHub tonight, but the real focus that I want to sort of direct everyone's attention to is to Git itself, and specifically command line Git. So let me repop in the chat room one more time the quick short link to the agenda tonight. It starts off with all the setup instructions and everything that hopefully you had a chance to walk through before this evening. I've got a whole agenda for this evening. I'm entirely open to questions and going off on other tangents based on what's interesting to everyone. So please, you're welcome at any point to ask a question. Either drop it in the chat message or wait when I get quiet for a moment and jump on voice and let me know. Down at the bottom below the agenda is a whole bunch of links to various things that we're going to probably hit tonight on Git configuration, because one of the other sort of points of this workshop is not just like, here's how to make a commit and here's how to push a repository, but it's actually to like look at some of the things that are defaults with Git and consider how bad or backwards or whatever they are, and then actually tune the thing to your own liking. So we'll do a bunch of configuration stuff tonight, see how that improves the overall workflow. So most of this is just down here, lots of documentation to different things. So you, of course, probably find that more useful in the future than you will tonight. A few other links back up at the top here in the agenda. I've created a GitHub organization called IITCOC-Git, IITCOC-GIT. And that's where everything that I do tonight, all the commits and everything that I make, will all go up into this GitHub organization. If you've never used GitHub organizations before, they're fantastic if you've got a project that requires having multiple separate repositories, or if you just want to like separate work for like a project team or a class or something from your students. I routinely use these things in all of my classes as well. So they work just like the rest of GitHub. It's just instead of polluting your entire GitHub account with different repositories, you have this contained space where things can go. So that's linked off the agenda. I've got a link to the Git documentation itself. I'm going to try to reference documentation a lot tonight. That's one of my version control, user test or unit testing, and documentation are sort of like the three major things that I'm always invested in and always eager to teach and whatnot. Whoop. If you're not talking, please mute your microphone. See if I can figure out where that one's coming from. There we go, got it. It's the Zoom mute whack-a-mole. All right, so I love documentation. I know certain developers really enjoy tutorials or video things. I like to go straight to the documentation because I have a low level of trust for most of the rest of the world. So sure, great that this tutorial from 2012 says X. What does the documentation actually say? So that's the other link. And then the third one that's just right up the top here is I'm starting to write a series of blog posts for the pragmatic programmers. I'm going to be doing these about once every 2 weeks throughout 2022 about Git configuration specifically. And so the first one is sort of will look very familiar to you because it's the same kinds of things that you set up whenever you have a fresh Git installation or for the workshop tonight. So those will be coming up all year long, about once every 2 weeks, something like that. So very excited about all those things. So that's it. Any questions from anybody before we get rolling any further? And yeah, let's hear it, Ray. Mm-hmm. Yes. Mm-hmm. Yes. I doubt it. I don't think I referenced WinGit. I referenced Git Bash. If you absolutely must run Git on Windows, Git Bash is the tool to use, because that will give you basically like a baby Bash style command line and command line Git. Oh, I see. Yeah. Mm-hmm. Right. So we want to focus on the command line portion of this. And let's go ahead and get this out right away, right? You can make Git commits and things on GitHub. GitHub itself has an application that's basically like a little graphical interface wrapper for Git itself. Um, Here's why you shouldn't use those tools. They're great when everything is rosy and fine. If you just are working on a project and you add your file and then you write your commit and you push it to GitHub, everything's great. Those tools are wonderful. The problem is that things don't stay great for long on any kind of Git repository with any sort of longevity to it. Inevitably, you're going to make a mistake. Your collaborators are going to make a mistake. You'll have conflicts and things like that. And then you won't have any choice but to drop to the command line to try to sort things out. And basic sort of user psychology is the last place that you want to be mentally when you've got a crisis on your hands, is solving that crisis in a brand new environment. You don't want your first exposure to command line Git to be when something's gone horribly wrong and you've got a project that's due in 10 minutes because it's almost midnight or whatever it is. So I emphasize in all of my classes, in my regular professional practice, it's command line, command line, command line. And again, that's because you want to build up those muscles, and it does good things for you as a developer. It doesn't matter what framework, what language you're writing in. Most of us are writing things of any complexity. It's split over multiple files, and you usually have to reference one file from another file. And how do you reference a file from another file? With some kind of path or with some kind of module system or something like that. So I'm always running the command line. It's all the time. It's the thing that just opens up first when I use a machine. Git, of course, is a command line utility. It's actually a command line suite that follows in the great grand Unix tradition of sort of the style and format and command line interfaces of different things. And the great thing about Git is that because it is a product of Unix, well, I mean, this was a version control system that was developed by Linus Torvalds, who created a little operating system kernel you might have heard called Linux. And Git was actually created to help do version control in a very distributed fashion on the Linux kernel itself. Prior to that, they just mailed patches around. And what's interesting is that even still, like if you go to make if you want to share some work upstream on Git or to the Linux kernel, you still have to use Git to craft your patch and submit it on a mailing list. So they don't the Git source code is mirrored on GitHub, but if you actually want to contribute to GitHub, you've actually got to craft patches and do things the old-fashioned way. That's way beyond what we'll cover tonight. But suffice it to say that there is a history to this tool, and there is certain values that are imbued in it right away. The other thing that you won't see me doing tonight, so I'm, a product of my age and time, but I don't like IDEs. I don't like integrated anything. I don't like package anything. I like to keep all my tools separate. So yes, you can get editors that have fairly good, in some cases, command lines built into them and terminal emulators and things like that. I like to keep everything modular so that if I decide I don't like this command line shell, or I don't like this editor I'm working in, or I don't like whatever it is, that I can pick up and move really easily. So I don't go for the whole integrated thing. And the nice thing is that you get a lot of stability out of that as well. So let's see. I should probably adhere to the agenda first with that whole huge opening preamble about Visual Git. Let's see. We've talked a little bit about POSIX compliant CLI, files and organizations. So yeah, again, questions at any time tonight, happy to talk about it. Other than that, let's just get going. So if you've never opened your command line before, in most Linux style operating systems or even Mac OS, it's called a terminal. You can find wherever that is on your operating system, and when you open it, you will see something like this. Mine is a little fancy, But the basic idea is that you are in your home directory. If you're in, used to looking at your files in some kind of visual kind of way, it looks like this, right? Where we've just got all these different files, and we usually are talking about folders and whatnot. The command line is the same exact representation of those things. It's just all done entirely on text. So we've got, there's applications, there's archive, there's certs. So all these things have the same representation here. One of the things that Git demands of users, and it's a hard habit to break, right? Like I've got my very pristine desktop here where I have a single folder there. Most of us sort of become digital slobs over time. You save your latest project on your desktop, or you're working on something that you downloaded and it's in your downloads folder. Git demands that you be organized with your files, because the way that Git works, the way that it understands what your project is based on the location of files within your file system. So we've got all these great capital letters that come with most home directories. So I always instruct in class for students, like, create yourself a directory called projects, just so that you've got a place where everything that you're keeping under Git control goes. And if you get fancier, you've got courses or whatever. But the idea is that have a place where you know that your Git repositories live, so that you're not guessing. So that you're not like, oh, I've got to remember how to change directories onto my desktop, or go dig around in the downloads directory, or wherever it is that you might be working. So we want to start sort of from a place of organization. All right. And the other thing I should say tonight, I am a POSIX compliant person, meaning that I expect a terminal to have commands like mkdir, like ls for listing files, all those things. If you're on Windows, you're going to be at a slight disadvantage because Windows is not a POSIX style compliant environment. There is the Ubuntu subsystem for Linux, which is fine enough for learning. There's Git Bash. If you've installed that, then you can at least install that. So I'm not going to make any special allowances for Windows tonight. So hopefully you can at least get the higher level Git stuff going on. All right, so I've created this projects directory, and I'm going to change into that thing. And then it is within the projects directory, or whatever my higher level, this is where all my important stuff is, each project of which is under some kind of Git control. This is where I work. This is where I get things set up. So let's do the sort of traditional Git 101 kind of thing, and we're going to make a to-do list just to sort of understand what version control is. I'm not going to make any assumptions about what you might have done previously in Git or what your experience is. So we'll start at the beginning here. So within this projects directory, I've got nothing in here right now. So I'm going to make a directory called to-do, and that's where my to-do list is going to live. So I'll change into to-do. Right? And you can see that I've got this nice command line. I do this because I have a hard time keeping track of everything that's going on. I need to know, or I like to know at any given point on the command line exactly where it is that I'm working. If you don't have a fancy command line like this, that's okay. You can always run the command pwd, which is print working directory. That will tell you exactly where you are on the command line. So if all you've got is like a little $sign or a %sign or something like that, you can always run pwd. It will tell you where you are. Because, as it turns out, where we run things, where we place things, where Git thinks we are, all matters in terms of us being able to do good, effective work on the command line. All right. Yes, I'm checking through the questions here. So I am recording this. I'm not recording it through Zoom. I'm recording this all locally, so it'll look much better than it's Zoom. And better yet, there's no chance of it recording any of you who are participating this tonight. It'll just be my face, my voice, my video. We'll have it all up later. All right. So back to the main thing here. We've got our to-do directory set up, and the first thing I'm going to do is I'm old school with my Unix commands. I love the touch command when I just want to create an empty regular file that's a 0-byte binary file, right? And we could just touch list.txt if we want to, right? Ooh, there we go. Nice list empty text file just like that. And at this point, if I type ls, I can see I've got this list text file that's sitting here. If I want to, I can now at this point actually initialize Git. So I'm going to do that. And when we do git init, that's what says, okay, here in this to-do directory, we're creating a Git repository. Now, what is a Git repository? It's basically two things wrapped into one. One, it's your actual source code or your article or your plans for world domination or your to-do list, whatever it is that you're tracking, whatever it is that you're building. So it's the files, and then it's a history of changes to those files. And what we do when we use Git is to build on that history. And what we'll see tonight is that we mean history in kind of two different senses when it comes to Git. On the one hand, there's the sort of going back to the beginning of time of your project, this long history where you can see how the project developed over time. That's usually more interesting for historical purposes than it is day-to-day developer life. But then there's the shorter sense of history in terms of what am I working on today or this week or this feature, and that's a much smaller unit of history. And that's actually the part that we're most interested in most of the time because, as you might have figured out, human beings, especially when they do things like software development, tend not to be so perfect. We fix one bug and we introduce, 98 more, whatever it is that's happening. So it's good to be able to control that history, understand how it works, and most importantly, how we can modify it, especially before we share some kind of work that we've done in a public way, whether that's pushing it up to GitHub for other people to work on, or deploying it to a server somewhere, or shipping it off to an app store, whatever it is that you're doing. We want to make sure that that sort of localized history is the best that it can be before we actually move forward with the project. So when we say git init, it initializes Git in a particular place. And here, again, I always tell students in my classes, don't go blind to terminal output. It's easy for your eyes to just glaze over and be like, okay, no, read it. Because it's telling you important things, and one of the other things I'll emphasize tonight is that Git will give you as many opportunities as you take to solve problems for yourself before things get out of control. All right? So when this tells me initialized empty Git repository in, I want to confirm that this thing actually is living in the directory that I said. Right? Here's something that happens far too often with students. They'll create this projects directory, and then they'll git init here. And then the problem is now is that we're controlling everything that ever would live in this projects directory, which is not what we want. We want one repository per project. So if you make a mistake like that, all you have to do is just nuke that little .git directory, wherever you happen to misplace it, right? And now I can say lsla. That'll show me my hidden files. No Git. I change back into my to-do directory. Right? There's my list, and more importantly, there's my .git directory. Now, here's a thing that you young people don't always appreciate, which is that before Git, there were a couple of other solutions, but primarily, before Git, we had two basic version control systems. There was a really old one called CVS, just like the pharmacy, except it stood for Content Versioning System. That's very old. That's back when the earth was still cooling, we had CVS. Then after CVS, we had a slightly better version control system that was called Subversion, or SVN. And the sort of architecture of those things, and since I set up my overhead projector, I'm going to use it, or at least I think I am, even though the aspect ratio is all goofy here. Hold on one second. Let me try to grab this thing again. Yeah, let me close this. Just reset this. There we go. There's the proper aspect ratio. All right, so in the old days with CVS and SVN, right, you had your computer down here, right, with your files that were living on that. And you could use a version control system like Subversion, but the trick was that Subversion or whatever version control system like that lived over here, and you needed to have some kind of network connection to talk to your repository. Like, it didn't live on your computer. You checked out a particular commit from Subversion, and then it was on your computer. And then if you wanted to add to that history, modify that history, you had to talk to a full-on Subversion server that, again, was most of the time other side of the internet, or at least on the local network within a company or something like that. What is so different about Git is that Git is wherever your project is, right? We have on the file system here this .git directory, and we can actually look at the contents of it, right? We're not going to go blind from that. We can, within this path here, let me clear my terminal out, right? Again, I can change directories into .git here, and if I do lsla again, this is what a Git repository, or what we would call the bare repository, is. It's just a set of text files that lives in a subdirectory called .git wherever your project happens to be. So there's no over there with Git, or at least there doesn't have to be. Now, of course, we love GitHub, we love doing all that sort of thing, but it's entirely possible to create a Git repository and never talk to GitHub, or to set up your own remotes someplace else. What's great about this is that when we move away from a centralized server, like with Subversion, we can have, with the same Git repository, we can have these .git directories living all over the place across the planet. Maybe we've got one that's up on GitHub. Maybe I've got another one that lives on my second computer. Maybe I've got another one that I have, for safekeeping on an AWS bucket or something like that. It's possible to have all of these things. And what's interesting is that with Subversion, you have a central, this is the repository where my project lives. With Git, basically what constitutes the repository is mostly a social arrangement. We all agree that this one location on GitHub or on GitLab or on a server that we're running somewhere, that's the main upstream project. But when you clone, and we'll get to cloning in a little bit, when you have a copy of a Git repository, it's as good and as complete as any other copy. This is fantastic for teamwork kinds of situations, because then we don't have to have a centralized server. We don't even have to have a network connection to do good work. We just have to have the social arrangement of where are things going to be. All right? So with that whole huge, long theoretical preamble, right, I'm going to change back out of this .git directory. Again, you can always check where you are with pwd if you don't have this. Back to where my little list is. And if I now run the command git status in here, let me clear this out again. If I run git status at this point, Git is going to tell you some things about itself. And of all the commands that I'm wearing my keyboards out at all time, git status is right up there with it. It's the answer to what's happening in the repository now and what's about to happen based on what we do next. So we can see that git status is telling us that we're on branch main, right? If you have a modern Git installation, if you did the configuration to set up the default branch to main, then you'll see branch main as well. Okay, we see that there are no commits yet. That's good. It's a brand new repository. It would be very weird if there were suddenly commits in this thing for whatever strange reason, right? So we're glad that that always opens up with no commits. And then it tells us about our untracked files, right? And we get a little hint. It says, use git add file to include, and of course this is a place where somebody needs to do a pull request, maybe it's me, to include in what will be committed. I think we could strike that in and probably have a better reading message there. But basically we have sort of a two-part, actually three-part depending how you do it. We save work like we always have since the beginning of, any kind of personal computer. We then add the changes that we want to commit using git add in some permutation. And then finally we make a commit, which is a record that is very intentional in history. It says, this is my project at this point. Let us save and preserve this thing for whatever reason, whether it's in the future we decide to branch off from that point, or if we just need to figure out, because there was a bug in the latest deploy, there is a command called git blame, and it, along with git bisect, are really great for tracking down exactly who's at fault when some kind of bug ultimately rears its head, right? So what we can do is just read what the terminal output is and respond to it. So I'm going to do exactly what Git says. I'm going to say git add list.txt, just like that. Now, I haven't actually opened up list.txt anywhere. If I want to, I could at this point open up an editor, but I'm going to just trust I use touch. It's a blank file, so I'm going to just write my first commit here. I'm going to say git commit -m. I usually say initial commit with a semicolon when it's my very first commit, and then I write my message, add empty list. Okay? We'll talk more about how we craft commit messages here in a second, because there is a style that you should adhere to for that. But for this first commit, everything is sort of a little bit different just because it's the first commit. All right, so we get this message when we've created a commit. It tells us it's the root commit. That's the initial commit. We have this interesting looking hexadecimal number here, which is actually something known as a SHA-1 hash, or at least the first 7 digits of a SHA-1 hash. We'll talk about that in a second, what that means. There's that commit message that I talked about and wrote just a second ago. And then we get a little bit of statistical reporting about what just happened. We have one file changed, no insertions, no deletions, which makes sense because, again, I just used touch to create an empty file on the command line. And then we see create mode. And, of course, if you are the kind of person like me who loves octal permissions on files, you'll see this is 664, right? That's read and write for the owner, and then it's read for both the group and the other people accessing the machine, list.txt. All right, now if I run git status again, I will get the happy message that I want to see when I am working, and especially when I've gotten to the end of the day. I will be told I'm on branch main, which is helpful information. You can see that I've got my terminal set up so that it always tells me what branch I'm on, but this is Git reporting to me that I'm on main. And then it says nothing to commit, working directory clean. Okay, so again, let's review. This is our working directory. This is where all the actual files, any subdirectories and sub-subdirectories and files with inside of them will live for this particular to-do list project. I cannot save a file off in my downloads folder or over on my desktop or in the documents folder or, you know, whatever goofball place it is that you might get used to storing files. Everything has to be here in this particular directory, this ~project/to-do, in order for Git to consider it as part of the repository that we're building here. All right? All right. So when we see that the working directory is clean, that means that the files that are living inside of this Git repository are completely in concord with everything that has been committed in the Git repository that lives in this .git directory. The second that we make any changes, we'll see that we no longer have this working tree clean. But at the moment when I finish up a work day or finish up work on a project, this is what I want to see, not having any dirty things around. So let's dirty the directory. I use an editor called Atom. It's open source and a bunch of my students like it, so I'm just in the habit of using it in classes. I prefer to open it from the command line just like this. And again, if you're the kind of person who's saying like, how am I ever going to learn the command line? How am I going to just open that to do Git? And I would say it's like any kind of strength training. If you're going to use the command line effectively, not just for Git, but for whatever else is that you're working on, then you've got to decide to use it all the time. If you're kind of like half the time like, oh, I'm just dragging files and folders around and hope I don't slip on the trackpad and have something drop and who knows where it went, right? Get away from that and just decide I am going to manage my files. I'm going to work and live on the command line so that these things don't seem quite as exotic when it comes time to use them and work with them. So Atom comes with the ability to install scripts so that you can launch it from the command line. I'm just using good old // which means, hey, Atom, open up this directory right here where I happen to be standing. And when we get inside, there we go. There is my one file that's in this project. So I'm just going to create some content here, right? My to-do list. Get comfortable with the command line here. See, and I should have called this Markdown because that's what I'm writing. Configure Git to my liking. And apply this knowledge everywhere. And that's the other thing, is that using Git, creating repositories should not be a special event thing. if you've ever heard, I'm hopeful this is a good Illinois Tech audience, so I'm sure everybody here knows the game Go, Japanese game of strategy that's played on a grid, and of course all the like teach yourself Go and any kind of instructional thing with Go says play your first 50 Go games as fast as you can. You're going to get pummeled and it's going to be terrible. And I would say create your first 50 Git repositories as quickly as you can. Don't run Git init once a semester or once a month. Like run it once a day at least. Get used to setting the thing up and understanding how it works, because that's the only way that we sort of develop both the muscle memory and then just the plain old sort of cognitive understanding of what it is that we're doing. It's by using that again and again and again, making sure that we've got those skills just ready right at the hand so we don't have to worry about them so much. All right, so here I've created just a few items on my to-do list. Good old Adam here is actually trying to help me. It's got this interesting green line here, and it has also turned my file in this little tree listing here. It's turned it yellow. That's fine on Adam. That's fine on it. Again, I don't trust it. In fact, as I've been working this last week or two in being back teaching classes, I've seen some errors where Adam thinks something has changed and it's not, or something has changed and it doesn't know. So again, the only source of truth for me when I'm working with Git is my command line shell, not a GUI wrapper, not even a representation on GitHub, frankly, because that can have bugs in it as well. So if I do Git Status now, having saved that file, right, and of course you can always, Command S or Control S a few dozen times. It's never just one Control S to save a file. We got to go a few times. Make sure we've saved it. And when we do this, we'll see that we've got this modified list.txt file here. Well, that's great that it's modified, but now what I want to know is what actually was modified here. What changed about this? So the way to find that out is to run another command called Git Diff. And I'm going to hit Git Diff and then return. And then I will show up on this screen of doom, right? And of course, depending on your operating system, it may be slightly different. Let's talk about the good things here first, all right? Good thing is that we're getting a diff output here. And what this is doing is showing me what has changed between what Git knows about, meaning work that we've committed previously, and what's actually in my working tree, all right? And that's these 5 lines. There's this heading line, my to-do list, there's the 3 items I wrote, and there's even this empty line of space between the heading and the little asterisk bullets there, all right? That's the good part. The bad part is that you've got this interesting end in parentheses here and a blinking cursor. And of course, if you touch many keys on here, you'll see that things start to disappear. You'll get flashes like this. Oh no, what are you supposed to do? What you have to do is hit the Q key here. And when you hit Q, you end up back out here on the terminal. Now, this is our first thing that we're going to fix on Git tonight. If you had that just now, if you did Git Diff and you ended up in what's called a pager, that could be kind of a pain in the neck, especially if it's not what you're expecting, right? Again, and part of it is that I really care about my diff here. I look at diffs all the time before I make a commit, and part of that is that is my opportunity to double check that I've actually done the things right. I cannot tell you how many times I've caught a misspelled function call or some goofy thing in my code, or if it's a piece of, prose that I'm writing for a book chapter where I'll catch some typo. Partially because we're getting to look at this in a slightly different way from how it looks in the editor where we might be working. So take a moment to appreciate this, and then also take a moment to think that it's sad when we hit the Q key and end up back out here at the terminal. Now there's no record of that. So if there was something that I was interested in, it's lost to history, which makes me very sad and upset. So here's the first thing that we're going to do as far as some basic Git configuration. That's to fix the core pager. Now there's a couple of different ways you can do this. One is to set, and let me actually just clear out my screen again. One is to do Git Config global, which means that's the configuration for all of the repositories that we touch on on our particular user account. For me, this is the user account I use to teach all my classes. So when I say global, I'm talking about like every repository I touch should have this rule. I'm going to say core.pager. Now, if you just are an anti-pager person and you don't want a page at all, you could do this. You could just say core pager and then just one quotation mark right after another. It's an empty string. We can do that. And now when I say git diff, Boom, I get the same output as before, but now it's just dumped right into the context of my entire terminal session, which is really helpful if I care about some kind of information here that's on the page. All right. If you're uncomfortable with an empty string, or if you're using some kind of tooling that uses pagers and Git output and things like that, a slightly safer route is to actually specify the cat program. If you don't know cat, right, we can say cat list.txt, and cat will dump out the contents of a regular file into the context of a terminal session. It's for concatenate, I believe. So what we can do instead, if we don't want to do just an empty string for pager, but we want the same functionality where it just doesn't page and it drops things out, we can say core pager cat like that. And now if I say git diff, again, it looks exactly the same as when I configured it with the empty string, but now we actually do have a legitimate program value there instead of just having an empty string. I'm kind of an in-between person most of the time. Usually I'm dealing with smaller diffs, smaller bits of information from Git, and I would prefer to have this just dumped right out in my terminal session. But if I'm working on some massive file and I'm doing some formatting, let's say, where I've got, I've discovered a huge chunk of a file where, all the method definitions were outdented the wrong amount and my linter is complaining because of that, then I can wind up with this diff that's several hundred lines long. And then it's helpful for me to have a pager to actually page through that. So my sort of compromise here is to use a slightly different value. And I should say, before you set any of these things, you should double check that you've actually got these programs, right? So you can use the which command, which cat. We do that. I get bin cat, right? It's in the binary directory like that, so you know it's an old program, standard with pretty much every Unix distribution on the planet. The pager that gets used in Git by default is a pager called less. If we say which less, we should get some location there pointing where the less installation is. So you want to make sure that you actually have access to those programs before you set any of these values, or Git will complain and throw errors at you. You'll still be able to work, but then you'll have all that noise on there. So one more time, I'm going to say git config global core.pager, and I'm going to set mine to less minus fx. And what that's going to do is it's going to allow me to have paged content when there's a need for it. And that need is that when the output from Git is longer than one of my terminal screens, which right here is running, we can see 90 by 25. So if I've got more than 25 lines of output from Git, it will go into a pager. Anything shorter than however big my terminal is at the moment that this output gets written, it'll just dump it on the command line. So I'm going to say less fx here. And now when I say git diff, it's going to look like I had set it to an empty string or to cat or something like that, which is great. Now if I want to game this a little bit, let me see if I can do this and just cinch up my terminal here. There we go. 7 lines is as tight as I can get this. If I say git diff now I'm in pager mode, right? And so I can go through the pager and eventually I'll get to that end. So this to me is a really nice compromise so that I can generally have the smaller, shorter pieces of things that I work with in Git, have them show up on the command line. But when there is need, that I get a longer pager for that. All right. Oh, and of course, Andrew is chiming in with a fancy pager. I'm not fancy because, again, I don't usually use a pager unless I absolutely want to. But Andrew, I'll check that out later for sure. All right. So one more time, what are we doing with Git? I'm going to run Git Status here. We've got this modified list. And if I do git diff one more time, this is what I'm actually going to commit. So what I'm going to do is 2 parts. First is I'm going to add this list.txt file, and then I'm going to commit it. And here let's talk about the rules for writing a commit message. There are rules. I know that it's common to say do stuff, right? Fix things, or ugh, or some kind of profanity, kind of depending on where you are in the overall scope of your project. Let's talk about professional commit messages. Let's talk about the way that you should get in the habit of writing these, even if it's just you by yourself, okay? First rule is that your first letter of your commit message should be capitalized, okay? Don't get all like emo rock and lowercase the whole thing, and certainly don't get all screamy and write an all screaming uppercase thing, all right? So capital first letter there. The second thing that we want to have is to make sure that we are starting with a verb in the imperative mood. All right? And if you don't know the imperative mood, it is when somebody gives you a command. Get up, all right? Get is the verb there. That's what you should do. Or let's use one without a preposition after it. Stand, right? Or sit, or leave, right? That's the same mood that we do with our commit messages. So what I'm going to do here is pick a very good verb called add, because that's what I'm doing. I'm adding, okay, we're going to say add starter items to list, like that. Add, not added, not adding, not adds. That's it. We're just doing the imperative mood. Now, the nice thing about the imperative mood, if that freaks you out in English, the imperative mood and the infinitive is the same. So add is the command, to add is the infinitive. So you just say add. The important thing is to not drop into past tense where you say added, or adds is the present tense, or gerund or whatever it is, the present progressive tense of adding. We want to say add. There's a couple of reasons for this. One is that Git will sometimes write its own messages. If you merge or do something or revert a commit, Git will write a message that says revert commit, and then it'll give you a hash like that. Or merge changes from branch, and then it'll give you something like that. So the professional style to drop in capital letter of that first thing, use the imperative mood, or if that freaks you out, just the infinitive form, no past tense, no present tense, add. It basically says, if you apply this patch, you will add starter items to the list, okay? Get in the habit of writing good subject messages. People talk about soft skills that developers have. This is probably the softest one. It's also the one that will gain you so many friends in your job, on your team, and certainly if you have any plans to contribute to an open source project. What we don't want to see is changed stuff, or fixing things, or hope this works, or please, Professor Stolly, can I have some more time? I swear, I actually did have a student once who asked for a project extension in a commit message. Don't do that, right? Unless you use the imperative mood, and then you say, hey, Stolly, give me a little bit more time. Oh, please mute your microphone. There we go. I got that one. Just go down the line here and play Zoom whack-a-mole like that. All right? So this is the way that we do it. And then the final rule here is no terminal punctuation. Don't put a period. Sometimes it's really hard, but don't put an exclamation mark. We just want to say add starter items to list. That's it. And then we close our quotation marks just like that. All right? Then we've created our second commit. And at this point, we can do a couple of things. One is we can ask Git to give us the history of the project. I'm going to say git log here. And when I hit return, I'm going to get a bunch of interesting information here. And we'll see that this is in reversed chronological order. Here, if we remember this from 7:28 p.m. tonight, that was my initial commit where we had this empty list. And now I am making a commit where we add starter items to list, just like that. We get the commit hash. This is how we identify commits in Git. I'm using Subversion for a project that I'm on right now. It numbers the commits. 1, 2, 3, 4. And the problem is that if you're talking about a distributed system, which Git is, where you and I can work on the same project at the same time. You've got your commits, I've got my commits, and eventually we're going to have to merge them onto a remote or something like that. If we did 1, 2, 3, 4, 5, well, I've got what I think is commit 3, and you've got what you think is commit 3. How are we going to let these things fight it out? That's all kinds of stupid problems. So with here, what we have is basically a cryptographically generated hash that takes things like the contents of the file, entropy for your system, your username, and generates this hash. And I think it's 128. I can't remember exactly how many long characters it is. That's not 128, but in that neighborhood, nice and big. And of course, if you ever have a collision within a single repository where I've got a set of changes and you've got a different set of changes that compute to the exact same SHA-1 hash, you will be in an academic journal someplace, because at this point, it's basically a theoretical idea that you could ever have a hash collision like that within a single repository someplace. So we identify these things by these hashes. And when we do git log, we get a history of what we've done here. And if I'm interested to know more, right, this tells me what I said happened, but why would you trust me? We can use another command here to inspect our history. called git show. And what I'm going to do is just grab the first 5 or 6. I mean, at this point, we could probably do the first 2 characters. But as a project matures and gets dozens and hundreds of commits, you're better off the first 5 or 6. I'm just going to grab these first 6 characters off this commit hash, and I'm going to say, hey, git show, and then I'm going to give it this particular hash. When I do that, I'm going to get both the log message here. This is the message that gets attached to the commit along with my author information that I told Git about through Git Config, right? User.name, put your name in, user.email is your email. There's the date it was committed, there's our commit message, and now here git show is actually going to give me the Diff output on this thing. All right? Yeah, there's a question here. Well, this is a good one. So what's the reason for not having punctuation? It is convention. Andrew is correct. But you can also have cases where you'll have tooling that may try to break on certain punctuation marks. And so it's just better to try to omit certainly terminal punctuation in there. It also makes it easy that if you've got commit messages that display on like a project page or social or something like that, that you've got a nice, clean message that comes out. I'll give you an example of that on all of the courses that I teach. The course itself I keep under version control, and if you go all the way to the bottom of on one of my pages, you'll see all this interesting stuff, and then we'll see that this was my last commit here, and I'm using JavaScript to make a lowercase a there instead of a capital A. But you get the idea that we were able to do that, and then I can have my own terminal punctuation. So if we're doing this in line someplace else, we don't have to deal with somebody else's punctuation. All right? All right, so Nadeem is asking what happens if there are multiple commits with the same 6 or so initial characters. In that case, Git is going to just throw you an error and say that that's an ambiguous reference, and then you'll have to go out and you'll say, okay, instead of the first 5 or 6, let's do the first 7. I mean, if you want to, you know, if you're this hardcore, you can always say, hey, git show, and then put the whole hash out there, same idea. When we're in a smaller repository or one with fewer commits like this one, if I say git show 24, okay, there we go. We say ambiguous argument there. So that's what it's going to show you. Probably because these are not the only hashed objects that live within a Git system. There's other things. So, you know, we can start playing with, okay, what if we say git show 240? That's still ambiguous. How about 2? There we go. So this one I'm getting away with 4 digits, right? So, you know, it depends. And on a longer repository, one with more objects that are packed in it, you're going to need more characters. But it's rare to have to go beyond 5 or 6. I don't think I've ever had to like had Git yell at me for using 6. And I've worked on some pretty long-lived repositories with, you know, well over 2,000 commits on them. Okay. So we're adding, we're committing, making history, basic Git 101 stuff. Let's go to Git 102 stuff and talk about how do we actually share these changes with the world, right? And usually how we do that is to create a remote on GitHub, but I want to show you something a little bit different because you came out tonight and you were hopefully expecting to see some different things. Let me show you something that I do on my computers. I'm going to go back to my home directory, which I can do. Let me clear this out. I'm going to go CD and then tilde like that, or you could just do CD by itself. You do print working directory. It'll tell you that you're in your home directory. On some of my machines, I host my own private, like super private, not like GitHub private, right, where you mark a repository as private. These are truly private on my own machine Git repositories that I can clone and push to from my own little empire of computers. So I'm going to make a directory in here called Repos, just like that. It's just another directory, just like we created projects before. And now I'm going to change directories into repos. And I'm going to create another directory. I'm going to create a directory here called to-do, just like that directory where I've got my to-do list, right? There's a little trace of it there. And I'm going to call this directory not to-do. I'm going to call it to-do.git. Now, it's a directory. I know it looks to your eyes like I've just created a file called .git. And this is actually convention. This is the same thing that you're talking to when you interact with a repository on Git or GitLab. It looks like there's a file out there called something.git. It's a lie. Okay? It's not actually a file. It's just a directory. Here, what I'm doing is creating my own remote. So now I'm going to do cd to-do.git like this, and I'm going to initialize Git again, but I'm not going to initialize it the way that I did when I created that original repository. Instead, I'm going to say git init followed by bear, okay? B-A-R-E, not B-E-A-R, so it's, yeah, like bear furniture, not bear like a thing that'll kill you in your sleep while you're camping in the woods or something like that. Git init bear, right here in this to-do.git directory, right? And if I do LSLA here, if you peeked inside that Git directory inside of our working tree on the to-do list, you'll see a very similar looking list of files and directories here as in this bear repository. Okay, that's it. I've created this bear repository, and now I'm going to leave, and I'm actually going to change directories back into projects/to-do. And now what I'm going to do is I'm going to create a remote that points to that repos directory, which I then might be able to access over SSH or whatever other network protocol I want to have my own little mini sort of place to host repositories. So I'm going to say git remote add local. We'll use origin in a second when we do the same thing on GitHub, but I'm going to say git remote add local, and I'm going to point to ~repos/to-do.git, like that. All right, so I'll say git remote add local. Local is just giving a shorthand for it. We hit return. Git's pretty okay with that. If I say git remote -v, I will see that I've got this local remote name here, shortcut name, pointing exactly there. So now I'm going to say git push local main. And when I do that, it's going to say I'm enumerating these objects, I'm compressing them, and I'm going to write them. And now I've got my own local copy of this thing, right? Which I can use to clone or work with from other machines. So you don't, even if you say the only reason I use GitHub or GitLab is to like be able to get my stuff, as long as you know how to like button down your system so you can access it over SSH that's protected by a private key and hopefully some kind of firewall rules on your home network or something like that, you can host your own repositories. They work just like Git repositories do too. And for me, I have usually both places. I've got like some remotes that live on a little machine on my network. That's its job. And then I've got the, GitHub ones as well for when, something happens to GitHub or something like that. You can never have too many redundant backups, and of course, Git makes it trivially easy to make those redundant backups all over the place. Okay, cool, that's fun trivia. Let's actually now go and make a public one here on GitHub. So again, back on this agenda document, I've got this IIT, COC, GIT, GitHub Organization, which I just closed the window on. That's great. Try this one more time. All right, so usually when we're creating new repos, yes? Thought we had somebody talking, but I'm just gonna, again, play mute whack-a-mole here. All right, so usually on your own account, you just go up to this little plus sign on GitHub, right? Looks something like this, and then you choose new repository. Here with the organization, and I screw this up all the time, it has its own little create new repository button down here in the middle of the page. The idea is still exactly the same. Now, my habit is always to name my repository after whatever it is in my projects directory. To do is what it is here. To do is what it ought to be on GitHub. Don't get clever and fancy and experimental with your names for things. Pick a name and stick with it to the bitter end, because then you won't have to have that cognitive overload. Oh, that's in the I hope I don't fail this class directory on my local machine, and it's on I'm going to pass because this is a great project on my GitHub account, right? Do that. I always like a short description. Demo to-do list. Okay. I'm going to choose public. Now that's it. That's as far as any grown-up should go on setting up a new repository on GitHub. Now, if you go below here, it will offer to initialize a repository for you with a README and all this. You don't want to do that because you have already run git init yourself. So your repository has already been initialized. If you initialize a repository on GitHub, then you're going to have a, tear in the space-time continuum because we've got an init here and an init over here, two separate lines of history, so it's not going to work. So all we want to do is give it a name, give it a description, say that it's public unless it's private. I want you to be able to see this work, so I'm going to actually make this thing public. All right? Not checking any of those boxes down here. We say create, and then GitHub is giving us information for how to talk to GitHub. Now, in the old days, and by the old days I mean sometime before last September, you could reasonably talk to Git repositories over HTTPS links. It was clownish. It was beneath your station as software developers and computer scientists and cybersecurity experts, but you could get away with it. Now the only way that you want to talk to GitHub is over SSH. That's going to involve some things I don't want to go into the workshop here, but basically I do have a link from the agenda to the documentation on GitHub for how to create an SSH key if you don't have one. Hopefully you all have one. If you don't, now's the time to generate one, right? Because you want to be accessing any systems and things like that using private public key authentication, not using a password, because it's just a matter of time, right? So once you've gotten your SSH key set up, then you can confidently use these SSH URLs. I'm going to just paste this thing onto my command line so we can see. So I'm going to add another remote, right? You can add as many remotes to a repository as you want. I'm going to say git remote add origin, because that's the conventional, this is where I got it from. Like if we clone a repository from GitHub, we're going to get it just like that. Git remote add origin to do .git, just like that. And again, you saw my little demo earlier, like, yes, it looks like a file, but it's not actually a file. It's actually just a directory path there. Everything we care about is inside of it. Now I can say git push origin main. Hit return, we'll see similar output as before, except now we're talking to GitHub over SSH. You can always check to see if you've set up your keys correctly by running ssh git at github.com. You'll be greeted with this request failed on channel 0. That's okay. What we do care about is this hi, Prof. Stali, or hi, whatever your username is. That's how you know that you've got your public key shared correctly with GitHub and it knows who you are. You're not allowed to SSH into GitHub. That's a good thing, but we can at least use this as a little sanity check to make sure that that's actually available to you. All right? So once I've pushed, then of course I get my GitHub representation of this little page here, this little repository with my list. All right. Nadeem, I do that all the time. Where I start typing commands there. Thank you, Catherine. Have a great night. Yep. Okay. So let's push a little harder here, because I want to talk about a few things, but let me consult the agenda and see what else that I promised we'd do. Okay, so we've done base configuration, repository locally, quick commit. We've talked to GitHub, referencing and pushing to a remote. We've done all those things. Now, we've done only part of the configuration here. Let's do these other things, because these are configuration values that will mean a great deal for your quality of life on whatever system you use. So this first one is core editor. And what happens is that if you, and let me just make another line on my list, set up an editor that I like with Git. Okay, so I'll just add this line onto here. Okay, if I do Git Status, right, we see that this thing is modified. Now, we're unfortunately too much in the habit of git commit -m and then writing the commit message right on the command line. That's not ideal, especially when you start to do more complicated things, or if you're committing to a project or trying to contribute to a project that requires you to reference issues or has like a custom footer or something like that. This is not the way to go professionally. So what we usually expect to happen is just to say git commit without any arguments. And when you do that, oops, first we've got to actually add our list.txt, but once we've staged that like that, right, I can do git status here, make sure that I've staged this thing. When I do git commit, it will open up an editor. Now, for some people who love Vim, and I do have a soft spot in my heart for Vim, this is great. This is a line editor, but for most other people, this induces a panic attack, right? And it's, you know, kind of a big ask for somebody to learn enough Vim to be able to do this. So if you end up in this thing, you can always hit, oh, and now this is where Zoom is interfering with my life here, because it was holding on to escape because I was hiding the meeting controls when I hit escape. So if you end up in an editor, like this is Vim, this is Vi actually, this isn't full on Vim, you hit escape, colon W and Q. Or actually, here I don't want to write. I want to just quit with an exclamation mark. Don't save my changes, okay? I've got this great editor that I use for everything else. Wouldn't it be great to use that with my commit messages and anything else that Git might drop into an editor for? So whatever you're using, I know we've got a lot of people that use VS Code in the program. Not sure what other editors are, but look, do some Googling, figuring out for what editor you're using, how do you run it from the command line. Now with Atom, there's this little install shell commands option here on the side. You need to run that before this works. And again, the sanity check for that is to just say which atom. In my case, I've got user local bin atom is where that thing is located. That's great. Once I've got that, I know I can configure this as my editor. So when I've got the editor I want, and when I know exactly how to work it, git config global core.editor, and then I'm going to say Atom, but it's not enough to say with most, especially graphical editors. Command line editors, no problem, because they just occupy the terminal space, and so they're going to just hold Git anyway. But when we're talking about a graphical editor that runs outside of the terminal, we need to give it a weight. This is almost becoming convention. I think for VS Code, it's code and then a space, 2 hyphens, and weight. Did somebody have a question? Oh, add. Add and said if you're really great. Yeah. All right, so I'm going to say git config global core editor atom weight. Now, again, I've already staged my file with git add, but now I can say git commit, and when I hit return, it fires open this commit message file right in my editor of choice. And what I love about this that you don't get when you do git commit -m on the command line and just write your commit there is that, again, Git is giving us an opportunity to make sure that we didn't screw something up. If I've got multiple files in play and I only mean to commit one of them and I've got all these modified files down there, that's my cue to say, whoa, I don't want to do this. Just close the file without doing anything, and it'll say aborting commit due to empty commit message, and then I can make my fixes, right? So yeah, if I've got small patches or something like that, I'll use git commit -m, but most of the time I prefer to write within the context of an actual terminal like I've been using an actual editor like I've been using for everything else that I've been doing. So same rules apply, right? And what I need to do is say add a to-do item for configuring Git with an editor. Too long. Okay, so this is like I have no problem being overly verbose. So one of the things that's great about Atom and a lot of other editors that are set up to work in a Git-driven environment is that they'll actually help you to keep your subject line where it should be. Here we see that this is at column 51. So a professionally crafted Git message has a subject line. That's basically what you're creating when you do -m on the command line. Subject line that you should hold to 50 characters. And then you can put in an empty line of space, and then we can write, let me write a love song or a novel or a poem about this wonderful commit down here. Okay, so now we can write an entire body to this commit message. So all this first thing, which is what we usually write with -m, is just a subject line, and then down here we can go and do all kinds of different things. What I often use this for is to record if I've got a command that I've run that's modified my code in some way or that's generated some new code. I will stop everything and do a commit right then and there and say, this wasn't me, this was this tool I use. And I'll copy the output right from the command line. Hopefully we'll see something like that soon. All right? When I'm happy with it, I save it, I close it. When we do this, then there's my subject line, added to item for configuring Git with an editor. Okay. If I do Git Status, we're working directory clean here. If I do Git log again, all right, now I've got this nice extra long part of my commit message here. And this is really, really good as another avenue of communication in team settings so that you can take some time to, maybe reference like, oh, we had this discussion the other day on Slack and that we were going to do this. And then there's a record of it, both in Slack and then here in your commit history. All right. Now, what's unfortunate is that even with just 3 pieces of history on this Git log, this is a lot to take in, right? It's just too much. What we really usually care about is we want the subject line and we want the first couple of digits from the hash. That's it. Turns out we can do that. Instead of just running git log by itself, we can say git log, 2 hyphens, and then the word 1 line. And when we do that, we get this output. Let me clear this so you can see how much prettier that is. Git log, 1 line. Like that, right? And this is how I usually look at the history on my Git repositories. I don't need to see my own name and email address 45, 105, how many times on the screen. I just need to know what the heck was I doing yesterday. Oh yeah, I added this item, or I fixed this, or I've got this work in progress commit here, whatever it is, okay? So this is, of course, what's that? Okay, yeah, no, all right, so Nadim is asking, is there a way to make that the default whenever you call git log? We can change some things about the default, but what I would suggest, Nadim, is let's make it, because git log is already a lot to type, and if you look at the way that your fingers have to move to type even log, it's error prone. So what we're going to do here, instead of writing a configuration value, is I'm going to just say, you know what, is there a command called git-l? And we see git-l is not a git command. Good. How about git-lo? Also not a git command. So now what I'm going to do is I'm going to write 2 aliases for myself, right? I'm going to write one alias. I'm going to say git config global alias l. Okay. So this is, we're doing this just like a configuration value. And now what I'm going to put in quotes is log 1 line. Like that. Okay. And again, we're working in old school Unix style systems, so we're not going to get 3 cheers and thumbs up and everything when the command runs. We're just going to get returned right back out here. So now with this alias L, if I type git L, there's my short thing. So not only can we say, yeah, that's the default, we can save our fingers from typing that awkward OG combination, right, or whatever it is, and do that. Now, because LO is also available, and because it's 2 more things to type, and because sometimes I might want to see the most recent one in full, I'm going to write another alias. I'll say git config global alias.lo, and then I'm going to just alias that to log. Okay, saves one letter, right? Git low now gives us that, and of course we can always add in arguments. If I only want to see the most recent item in the git log, I just say -1. And even our git-l command now, we can also say -1 on that, and it's only going to give us the first one. Or if we can want to see up to the first 5, we've only got 3 on here, but we can see it like that. All right, let's look at our git config here real quick. Git config global list. Okay, we can see that we've built this out. Don't pay attention to this GPG signing stuff. We'll have to do that as a subsequent thing, but basically I cryptographically sign all my commits in a way that Git understands who I am, or GitHub knows who I am. And we can see down here we're building up this nice little list of aliases. And actually one of the other things I love to alias is git config global list, because I'm often working across different computers. I can't remember what I'm doing. So I will do git config global alias GCL for git config list. And I will just alias that thing to config global list, like that. So now when I want to see my configuration, I can say git GCL. Although that G doesn't make much sense, does it? That should be CGL, config global lists. And let me just change that. How do we change it? We just run the same command again, although now we've got a problem because we've actually got this GCL. So what I can do now is say git config edit, like that. And when I say git config, and actually we should put global here, global edit. Because I've configured Git with my editor of choice, it's opened up my configuration file right here in Atom. I could go find the offending alias and say, oh, this should be CGL, not GCL. I can save it. Yes, sir. I don't, but here's the thing about that. Git, and I think this is still the case here, if we do git config global show origin, I think that's the command, show origin. Maybe it's just origin. No, show origin. Yeah. Git config global list show origin. There we go. So we can see that this is all being stored in a tilde, right? In a tilde file, or well, tilde because it's in my home directory, .git config. However, and I can't remember exactly what version of Git it was. I think it's in the Git 2.2 series. The preferred place now to store the Git configuration file is actually in a .config/git. So it would be in config, config/git/ I think config is where the newer ones should go. By default, if you don't create that yourself, Git still sets it up in the home directory like this. I like it to stay there. So the very short answer to your question is I work across different computers, some of them with older installations of Git, so I don't always remember where my configuration file is. You're absolutely right. There is nothing in the world wrong with saying Adam tilde Git config like that and it opens it up. The problem is if that's not actually where that file is stored, then you're going to just have an empty file and then confuse things even more. So for me, this is, if we went through all the trouble to say, hey Git, I want to edit my file, well, let Git worry about where the thing actually is. And then we can say git config global edit, and then Git will be in charge of opening the correct file. So that's the main reason for doing that. It's also nice, yeah, and if you, because you have your global configuration file, but you can also configure Git on a per repository basis, and that's where it's super helpful to just say git config edit. I don't want to remember the path in the Git subdirectory as to where I have to go. I can just say git config edit, and it opens up the file for that specific thing. So yeah, great question. Thank you for that. All right, so we were doing these aliases, we were doing pushing things, we're 8:14, we've only got 45 minutes left, and there's like 99% of the agenda left. So let's see where we're at. The editor thing is really key. Excludes file. Let's do this one really quick, right? If you are a Mac user, let's say, or a Windows user, or a Linux user, every file system has what I call poop. Like where you open the wrong thing in the wrong program and then suddenly you get a temporary file. You get a thumbs.db, or in Mac OS, it loves to poop out DS store files. So let me go in here. There's my to-do thing. I'm looking at this even though I shouldn't be. And then I close this, and now if I go back to my terminal and run git status, it's going to be like, oh, it actually, this one, I must have configured this already. Maybe not. Maybe I need to make some changes here. If I change the size of this and adjust the columns or something like that. Isn't that funny? When you actually want it to do that, it goes away. All right? Okay, so desktop ini is another one. For some reason, maybe I've configured something, or maybe this is just new in Mac OS 0, but for some reason, different operating systems just have their little things that they drop around. So what we can do is I'm going to touch a Git Ignore file in the root of my repository. Let me see if I actually have that. Do I have a Git Ignore? I do now. Do I have anything in it? Ah, I do, which is okay, but there's nothing there, so that's fine. So here I'm going to use my editor to open this Git Ignore file, and then I will go with my system things. So I know to say, yeah, if you ever see a file called dsstore anywhere, don't hang on to that thing. On Unix and Linux style systems, temporary files are often marked with tilde at the end. So a star tilde is a great, and again, this is a global thing. We'll often want to have per repository Git Ignore files, because if you're working, in particular language that drops make files around, or a modules directory or packages directory, you want to ignore all that stuff. But here we're talking about like operating system level things that you would be embarrassed if you accidentally committed, right? So we can do desktop.ini, and we could do thumbs.db, like whatever these wacky things are, any file that you have that show up again and again, right? Like maybe you just decide, every repository I work on with groups, I have an enemies list.txt file, and I don't ever want to commit my enemies list that I keep with every project. This will prevent you from that embarrassment, right? All right, so let's do that. We've got this. I'm going to then do a git config global. And here I've just had a little lapse in, there we go, core excludes file. Core excludes file. And I will set that to my global Git Ignore. Now, it's important to always have, if you do have a project that part of its build or its package manager, whatever you've got, if there's extra stuff around, you want to include that as a Git Ignore file in the repository itself so that none of your other collaborators do that. The contents of our global Ignore file is usually more of like, this is the weird stuff that my operating system does that I just don't want to ever embarrass myself by having it show up. Yes, you can, and Andrew's exactly right. You would just put in the stack. And Andrew, you don't have to glob like that. Basically, if Git sees that each line in the Ignore file represents a pattern, and if Git detects that pattern, with wildcards and things like that, anywhere along the path, it'll ignore that. Yeah. And the documentation on that thing is really good too. All right. Say it again. Okay. Oh. Yes, you can override. So yeah, if for some reason a particular repository should have that cruft, then yeah, you can always do the negation on that. Okay. I'm going to do a quick new repository partially to show off the status show untracked files. So we'll a bit ado to the to-do list. Oops, went a little too far here. And I'm going to actually just make another thing that I'll just make a little simple basic website in HTML, CSS, and JavaScript here because I want to talk about Git as it's spread over multiple files. So I'm going to make a directory here. I'm, again, back in my projects where I keep all of my different things. I'm going to just make one called website here. All right. And I'm going to change directory into website. And now I'm going to just use the touch command and the make directory command to just set up a basic website for myself. So touch the home page, index.html. I'm going to do make directory with the path argument to get assets CSS. I'm going to do make directory assets JS for my JavaScript file. And then I'm going to just do some more touches here. I'm going to say touch asset CSS screen.css for my style sheet. I'm going to do touch assets JS site.js for my site-wide JavaScript file. And now finally, I'm going to do git add. Oh, I'm sorry, not git add. We're jumping the gun here way too much. I mean git init. And now I see, again, have I created this Git repository where I expect it to be? Yes, this is for controlling my website. So I'm going to do that. If I run Git Status now, it's going to tell me what we saw earlier with the to-do list, branch main, no commits, untracked files. Now, here's the lie, right? Yes, there is an untracked index.html file, but there is no such thing trackable in Git as assets /. Okay, this is basic kinds of things that is important to know with Git. Git only tracks regular files. If you create an empty file, I'm going to just create a directory here called evil, right? Yeah. I'm sorry. Thank you. Yes, that's what I meant. Empty directory. So I've got this empty directory called evil. When I run git status, it doesn't recognize evil because it does not track empty directories. So let me remove that evil directory. Oops. Let's get the right spelling of it though. All right. And then the other thing that I will do for the sake of keeping GitHub happy is if I've got a situation like this, and here I'm going to use the tree command, which I love, right? I've got assets, and then I've got CSS with screen.css. GitHub and other tools will kind of choke at like a truly empty directory that only has other subdirectories. So oftentimes I will do a touch assets.keep and put that .keep in there so that GitHub will be happy. And of course, the tree view here, the way I'm writing it doesn't do hidden files, but if I do lsla here or lsla assets, right, there's that keep file. But I don't like this because let's say I've run a tool or I've set a bunch of things up and I don't actually want to commit all of those files and assets using git add dot. I want to do it in a finer grained way. What we need to do here is set up another thing. We're going to do status show untracked files, and we're going to configure that thing to all. So here we go. Git config global status show untracked files, and we're going to set that to all. And when we do this now and say git status, boom, now we actually get every single file that it actually knows about, so that if we decide, let's do this. Let's prove why git add is important and not just an annoyance, right? I'm going to say git add index.html, and I'm going to do assets.keep, right? If for some reason it was like, oh, that should be a carefully tracked thing. So now if I do git status, we can see I've got 2 files that are staged, 2 files that are down below unstaged. So I'm going to say git commit m, add homepage and assets. And actually we could make a good argument that if you're using the word and in a commit message, you're probably doing it wrong. It probably should be 2 separate commits, right? So let's rewrite the commit message. We'll say add essential site elements, right? Meaning that we've got the assets and we've got the index.html file. And now we can do a subsequent commit here. Add essential site assets. Like that. All right. Now, I want to move very quickly here. So I'm going, because we are just out of time. It always sounds like 2 hours. What am I going to do for 2 hours? And then I forget I'm me and I yak too much, right? All right, so I'm going to open up this project now in Atom. I'm going to use some very, very quick shortcuts here that I've got. Okay. Now, and actually, let me point that out because I teach web development all the time. I have this shortcut built into my editor to quickly get a skeletal piece of HTML down. Oops, I waited too long there. I could just hit return and there it is. That's the same kind of thing. Like if I've got a shortcut, if I got something that's generating code, I don't want to just dive in and start manipulating it. So I'm going to go ahead and make, if we do git status here, we've got a modification to this index.html. I'm going to say git add dot. And then I'm going to do git commit. And again, I'm going to open up my full browser. I'm going to say add skeletal HTML. And then down here, I'm going to say, note, this was generated from my RHTML shortcut in Atom, right? So if anybody wonders, like, where did this show up from, it's that. And if they discover that there's some error in some little shortcut or something, then I can know to track that down and actually fix my script. That's the problem. All right, we save that. Let's go ahead and set up a remote, git remote add origin. And don't worry, I am going to post this whole video. I know you're all like, God, he's really going fast now. I am. I will post a video to YouTube. I'll make sure everybody gets the link, whether you're here tonight or not. And then you can go very slowly and pause me and shake your fist at me and whatever you need to do to get through it. Let me just go ahead and create this new website repository. Same things as before. Create this. I'm going to copy the SSH URL. Push that thing up. Okay, so now you can see the work that I'm doing here. Now, I should add a title because that's what every web developer ever tells you. Every page needs a title. My great demo website. And the other thing that I might notice is that there is a reference to this screen.css file here that is wrong, right? That's looking for a file called screen.css in the same directory as my index file, but actually I've got mine in this deeper directory structure. So I'm going to change this to assets css screen.css like that. All right, so I make both those changes because I'm a very excited person. But when I go to git status now, and then I say git diff, can you show me what's going on? I've now got 2 changes to this file, but arguably, those changes are not related. In the first one, I'm creating a piece of content, and in the second one, I'm correcting a path, right? So what I'm going to do here is, I can do a couple things. I want to make sure that my commit history is clean. I can just undo one of them, commit the whole file, or I can do what I love to do all the time, which is to drop into patch mode. So rather than saying git add in the name of the file, I'm going to say git add -p. And when I do that, I will get this display where Git will help walk me through all the changes in a particular file. And so in this case, I can say, do you want to stage this hunk, which is a very 1950s sounding kind of question, but basically this hunk of code, do you want to stage it or not? We can say yes, we can say no, we can quit. The option that I want is actually S, which is to say split this thing. So I'm going to say split it. And when I say split it, now it's saying, do you want to stage this migrate demo website? I'm going to say no. I think I want to just take care of that actual legit error that I've got in there, which is that it's going to look for a style sheet in a location where there isn't one. So I'm going to say, no, don't stage this one for now. And then say, okay, do you want to stage this hunk? And I'll say, yes, that's the one. And then I do that. And then when I run git status, I'm in this interesting place where I have a single file called index.html, and it has changes to be committed, and it has changes not staged for commit at the same time, which is really interesting. Now, if I run git diff at this point, all it's going to report to me is the change that I haven't yet staged for commit. If I want to see what the diff is of what I'm actually about to commit, I need to do git diff staged, like that. And that'll tell me exactly what is about to go into the next commit that I make. This is super important. I cannot tell you how much professional embarrassment I have saved myself, how many hours of like figuring out some dumb thing by just, especially when you get fancy with going into patch mode or dropping it into edit mode, do a quick git diff stage to make sure that you are committing only exactly what you think you are. In fact, that is such a common thing for me to do that I feel inspired to write another alias, Git Config global alias DS for diff staged. I'm going to just change that to diff staged. And now I can say git ds, boom, and it'll tell me this is what you're about to commit, Stally. If you run that command, this is what's going to happen, all right? So fine, I will say git commit -m. Don't need to drop in an editor for this one. Fix path to CSS file. Okay, just like that. Do git status again. We can say git add index.html. I'll do git ds. I'm pretty sure it's just this added title. It is. So now I can say git commit m, add title to site. All right. Just like that. Now, I like this. This is good. I might be the kind of person who thinks, though, that maybe it's better to make sure that your UTF-8 character set shows up as the first thing inside of the head, right? So that's known right away. It doesn't really matter, but it works really well for this demonstration, right? Because we've been doing these git diffs here, and we can see that when we have a line that is changed, right? It's represented as one line that's deleted and a new line that's inserted, just like that. Now, when I do git diff right now, having moved this title, this output is kind of a lie. I did not add a new line called title and stick it up here, right? Although that's the way that the diffing algorithm is treating it. But even if we're accepting that that's how the diffing algorithm is treating it, this is not a deleted line and a new line. This is actually a copied line. We're just copying it from one, or actually a moved line, moving it from one line of the file to the other. Where we run into trouble with stuff like this is where somebody introduces a mistake. Like, there is no such thing as UTF-8.7. But when we do git diff now, now it's tracking that one as a changed thing, which is actually kind of good, except if we've made a mistake in copying and pasting a line someplace. So what I want to have happen is when we have a line that's genuinely changed, let me do something like put a body ID home or something like that so that we can have a genuinely changed line here, right? Git diff. Oh, does it? Okay, fine. No self-respecting web browser. Yes. Does it really? I thought we left ASCII. Interesting. Because I thought the last 7-bit character set that was in any broad use was the original 128-bit ASCII. Now you got me something to Google later tonight. Anyway, point here is that we've got a line that looks like it's moved because we've actually switched this thing around. And we've got a new line here that's actually changed. And when I do git diff here, this gets a little harder to detect what is actually going on, because here we have a line that's genuinely changed. And here we have a line that is genuinely moved someplace. What I want to do is configure Git so that when I diff, it colors lines that are just moved someplace differently from lines that are genuinely added or genuinely removed, which is basically the same as modified. And what we want to do for that is actually down here a little bit. Diff color moved. I'm going to set that to zebra, and I'm going to do this color move WS that allows indentation change. Hang on a second here. We're going to say git config global diff color moved, and I'm going to set that to zebra. Okay, and when I do git diff now we've got different colors operating on the page. We've got these two that are pointing out a line that has been moved. And we've got these two down here, which is normally what we see when we've got a line that's added or removed, something like that. Now, let's make it an even more complex picture here. I'm going to just indent this body tag for whatever. Or we could even do this on the head tag too. We can indent this whole thing. Right? And now when I say git diff, now it looks like there's a whole bunch of stuff that's changed. But actually the only thing that's changed in most of these lines is our indentation. And of course, there is nothing more common in the world than as you're refactoring a file, suddenly discover like, oh yeah, you know, this method definition needs to be indented, or the linter's complaining. So we can add another line here. And again, all of this stuff is referenced in the documentation below. I'm failing miserably tonight, but I want to say git diff color move WS and set that to allow indentation change. Woo, cute, out of here. Git config, actually I'll be able to just up arrow here. Git diff color moved to git color moved WS, and I'm going to set that to allow indentation change. And now when I say git diff, now it's a little bit more complicated to read, but we can actually see, yeah, this is not the greatest I've ever seen. I'm pushing on it a little too hard. But the bigger thing that matters to me is looking to see where we have lines that have changed. Yeah, there's just too few lines in here, and this is actually not working quite the way I want it to. But when we're not being so fancy, let me move this back so we're not indenting everything, because that was unnecessary to do. When we go back here, now it's easier to spot lines that have been moved versus ones that have changed. Because, you know, if you're copying and pasting things around in a file, it's really easy to forget that trailing character or something like that. If that happens, where now I've actually modified the line in copying and pasting it, right? Now we can say, okay, that should actually be a copy. Why it's being treated as two different lines is because, oops, I forgot to copy that extra line on there. All right. So let's put that back on. All right. The other thing I want to say is that even though I have made the mistake here of making all these extra commits all on the main branch, generally it's not good practice to make all your commits on the main branch. Your main branch should always be like the deployable code for your project, or the code that you're going to turn in for your assignment or your article that you're working on. It should be the very best, latest, well-documented test passing work. So here, while I've got this dirty directory here, I'm going to actually move over. I'm going to say git switch C, which is me rewiring my brain. These are the modern commands for making a new branch. Git switch C. It used to be something different. I'm not even going to say. Git switch C. I'm going to just create a long-lived branch here called dev, which is where I can experiment with doing my different work. I can stage these changes individually. I'm going to just add patch here. Now, add patch mode doesn't necessarily pick up on those fancier diff things, which is sometimes unfortunate. So it wants me to stage. I'm going to split this thing again. I will stage that hunk. I will stage that hunk. But I'm not going to stage this last one. So now if I do git ds to diff staged, I'm going to just say git commit m reorder elements, right? That's reorder. That is an imperative mode. Reorder! Okay, reorder elements in the head. If I do git diff now, I can see, okay, we've got body ID home, so I'm going to just add that one. And I'm going to say git commit m, add a unique ID to body element. Okay, just like that. And now I can say git push origin dev, just like that. All right. Now let's see. We got 20 minutes left. I wanted to talk about conflict resolution, and I want to talk about Git rebase and how we can get commands to, or commits to be shrunk down. So let me make some other silly little commits here. Whoop. I'll just do a quick heading. This is my site. All right, so I'll just Git Diff that out. Add a heading 1, let's say. And then maybe I'll do a paragraph of content, right? When I'm working on a new feature, not necessarily a website, something like this, but when I'm working on a piece of code, when it's a newer feature, this is how I often work. I write very, very small commits, right? Because what's the advantage of committing? Like, why stop every few minutes of work to make a commit? And the reason is this: if I dig myself too much of a hole, right? If this paragraph that I've made, if that's a mistake, right? And again, let's use our imagination that this is some, method definition or something that I'm working on, or some class definition or some constructor or something that I really just, I've gone too deep, I've made a horrible mistake. I can always say git restore index.html, and then boom, that change is gone. That mistake, that really bad idea is gone. So the more frequently you commit, the better the chances are that you can get back to a good spot and then restart the problem again. So I'm a big fan when I'm doing development on my own, privately, make real nice small commits, okay? Now, regretfully, I actually did want that thing, but I think I can quick Control-Z and get it back, which is not bad considering that went away because of something I did in Git, that Adam was aware enough to say, oh yeah, we can bring that back, right? And then I can say git add index.html again, git commit add a short paragraph of Latin or whatever, right? And so eventually, if I run my little git-l, I can see there's my main branch. That's the good deployable version of the site. And then here's all the stuff that I've been doing over here on this dev branch. And what I want to do is I want to bring my work on this dev branch over to the main branch. And I have a choice to make here. One would be just to do a straight merge, and basically what would happen is that main would look exactly like div. But I might say, all these little things, do we really need to preserve that I created a heading 1 and I made this body element and then I reordered these things in the head? Actually, maybe that's okay, but I want to do these other things. What I want to do is I want to take all these little commits and I want to squish them together in one commit that just says improve the home page, right? Because now I've got the home page looking the way I want it to. So here's what I'm going to do. I'm going to create another branch. Ordinarily, I will do this in place because I'm confident. If you're not confident, you can always create another little branch for yourself and test out what you're trying to do and then work from that one or delete it if it doesn't work. So I'm going to switch to a branch called squashed dev, right? Because I'm on the dev branch. Now I'm over on the squash dev branch. And what I want to do here is to use the git rebase command so that I'm basically going to take these 4 commits and squish them into one smaller commit. And the way I'm going to do that is I'm going to say git rebase interactive. And then what I need to tell rebase interactive is the commit that I want to keep. And in this case, that commit is the tip of my main branch, this add site title to site. So what I'm going to do is I'm going to rebase all of these other commits on top of that commit. So it's basically like everything I've done since this commit, fair game. We're not going to lose any changes, but we can change the way that the history is constructed around them. This is for certain open source projects. They demand that you make just a single commit. Even if you've written some beautiful patch and it took you 80 commits to get there, they want you to take those 80 commits and squish them down onto a single one. So I'm going to say git rebase I want to rebase on top of this commit that's identified as that. And when I do that, I'm going to thank the gods that I chose to set up my editor, because now we've got a whole lot of interesting things here. We've got pick set next to these 4 commit messages, right, which are ordered in reverse chronological order. we can see that we've got commands here. We can pick, we can reword, we can edit, we can squash, and we can fix up. Now, a lot of developers like the squash command, and I actually tend to like fix up because it hangs onto the commit and then just ignores its commit message. So what I'm going to do is I'm going to say I want to edit the commit message for reorder items in the head because I'm going to squish everything down. That's going to be lost to history. And usually would just leave pick and squash. Again, I'm fancier than that. I want to edit this so I can get my commit message exactly the way I want it. And then rather than squash, I'm going to just say fix up. And what fix up will do is hang on to my changes, but ignore those commit messages. And so when I'm happy with this, what's going to happen is it's going to take these 4 commits, squish all of their changes into one big commit, and with edit, it's going to give me the opportunity to edit the commit message that'll go with these squished commits. All right. So once I'm happy with these commands, I just close the file. And then I will end up in a situation that looks a little bit panic-inducing because now it'll say 0980 ABD. If I do Git Status here, it's going to see that we've got 1 command done. We've got this edit. We've got 2 fix up. And so what we need to do is to do Git Commit Amend to amend the current commit. That's where we do this. So now I'm going to just do Git Commit Amend, which is going to bring up that old reorder. And instead what I'm going to do is going to say add full content to home page, let's say. Close that thing. And then we'll see this new commit. We're in this detached head state, which usually you're in big trouble when you end up there, but don't worry. We're in good hands here. So now all we need to do is say Get Rebase Continue. And then we see successfully rebased and updated refs head squash dev. Now, when I say git log on squash dev, there we've got our add full content to the home page. For quick reference, let me actually check out or actually switch to my dev branch, git L, right? These were all the commits that we had before. We had 4 of them. Makes it a little bit confusing to see where everything is, right? But the main thing to watch for is this add title to site. Here now we've got add full content to home page, just like that, okay? Now, let's go the other way. Sometimes you make a commit and it's too big. I'm going to just use my squash dev and we'll just switch to that one. And I'm going to do, let's do a new branch. We'll call it switch and we'll do, I don't know, explode dev. Like that. And I'm going to use that same command. I'm going to use git rebase I. Let me do git log here, or actually git L. All right. And it's actually this commit that I want to fix. So I'm actually going to rebase onto the same commit, git rebase I, onto that same commit. Except now I'm only going to have 1 commit to work with here. And it's going to say, I'm going to say, I want to edit this commit. That commit is a problem. It's too big now. All right, so if I close this thing, I get back out here. Now, if I run Git Status, it's saying you've got 1 commit. Now, what I need to do here is actually roll back the pointer to the commit that actually is before this one, which is this 84523. So I'm going to use the shorthand for that, git reset head, and then a caret like this. That takes it back, and now if I do Git Status, it's going to tell me my index.html is modified, and if I do Git Diff, there's all of our changes, right? This is everything that was previously separate commits. We squashed them together into one big commit, and now I'm flipping the demo around to say, okay, what if we'd done this originally? We want to make smaller commits. So now what we can do is we can go into patch mode. We can say Git Add Patch, and we can say stage this hunk, or we can say split it up. And I might say, you know what, this was a stupid idea. We never should have had that, extra title switch thing around there. So I'm going to say, no, don't stage that, and don't stage that. Go ahead and stage the body thing. That looks good. And now if we do Git Status, we can see, okay, cool. And now I'm going to make a commit just like any other time. I'm going to say add content to HTML file, like that. And now we've got this Git Status. If I do Git Diff, all that's left is this little switcheroo, which was a stupid idea anyway. So who wants to do that? So what I'm going to do here is just say git restore index.html, And boom, that change is lost to history. And now I can say Git Rebase Continue. Boom, and it finishes it up. When I say Git L here, in this case, we've actually gone back to just having one commit since I just put everything in there. If we say Git Show OE6D, 0E6D3, right? There's our changes. There's no record of that wacky place where we actually flipped things around. All right. Now I want to get these changes onto my main branch. So I'm going to say git switch main. And I'm going to git rebase explode dev. But in that case, it's not really going to rebase. It's just going to be a merge commit because it's going to just put that one commit on the end of my HTML file. All right. Now, here's the other thing. I promised we would talk about conflict resolution with this thing. So I'm going to quietly pretend I've got a second computer here that I'm working on this website on. Okay. And I'm going to say git clone. Oh, hang on a second. Let me go back here and grab this thing. Remote V. Okay, so I'm going to grab this thing. I'm going to pretend with me that I'm on a completely different computer someplace, right? And we'll do git clone website, and we'll call this like El Otro website or El Otro computer website, something like that. The exact same repository with the exact same remote, right? If I do git L here, it's not because we haven't pasted those other changes here, or we haven't pulled those other changes here. So let me just make a quick commit here, right? This is what can happen in a group situation where two people make commits on the same branch if you don't have a better organizational scheme. So I'm going to just open this thing up, and I don't know, maybe I get creative here on the CSS side. We just say HTML background black, color white, so we get a nice inverted thing or whatever it is, right? And then we can do Git Status, we can do Git Diff, and then we can say Git Add dot here, we'll say Git Commit M. Make the site display light on dark, like that. All right, and then this person is just going to quietly push that thing back up. Let me not use my thing. Git push origin main. La 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 la. Right? Maybe it was me working on a different computer. Now I'm back here joining you on this computer where I have been working on, and I've got all of these great new commits on my main branch that I can't wait to show. Because again, origin main, that's what my origin branch knows about. All right. Now before I do this, I'm going to set another property that I promised that we would talk about tonight, and that is this one. The, where is it? Pull FF, where are you? Yeah, there we go. Pull FF only. And what I'm going to say here is git config global pull fast forward only. Meaning that when I say git pull some remote, the only time I want that to be successful is when it's a fast forward, which means that here are my commits. There's some new commits up there that work completely with the history of my other commits down here, and then we just fast forward the head to that latest commit that comes down. We say only do that on a pull. Now, because from this other computer, I've pushed that CSS commit up, when I go to do git push origin main, I'm going to get this error message. Oh no, right? It freaks out. It's going to say failed to push some refs. I wish we were in a room together now so I could say raise your hand who has seen this error message before, right? This happens. This happens when you have a remote that you're talking to that has changes that your local branch doesn't know about, and your local branch has changes that your remote doesn't know about, all right? Now, most people will start to panic and be like, oh, we need to force push, right? Don't force push. If you can possibly avoid it, don't force push. So here's what I do. When this happens to me, and I swear this happens at least 2 or 3 times a week, because I work across multiple computers, and usually I'm pretty good about doing git pull before I sit down to work, but sometimes I got an idea that I'm really hot on, and so I just want to do that. So what I need to do here is first I'm going to make sure that I've got everything that's known about my remote repository by doing Git Fetch. Here's the secret. When you run Git pull, it's basically a wrapper around two separate commands. It does a Git fetch, first of all, that's how we figure out what commits are actually up there, and then it does a merge, all right? Which is why you can end up with merge commits, which I really, really don't like. That apparently is going to have to be topic for another Git seminar here. But, so I've done fetch, so now I know what's on origin main, and what's great here is that I can do a Git Diff, just like we've been doing, except I can diff against origin. I can say, hey, what's the difference between what I've got and what origin main has? And when I hit return, it'll tell me, okay, look, there's some changes here in terms of what I've got. There's some changes that it's got, right? And I actually find, because what happens when you say git diff origin main is that it uses your current branch that you're on as the second argument. So usually when I'm diffing against a remote branch, I will explicitly state the name of my branch that I'm sitting on first and then compare it against the opposite branch. Because what I'm basically asking here is, how would I have to change? Sorry, I've got like wacky, let's see, hide the, okay, there, thank you, Git, or Zoom or whatever. What do I have to do to my branch main to get it to be like origin main? And when I hit return here, now it'll say, oh, well, what you would have to do is you would have to add this CSS in, and you would have to delete this content and make it empty, and you would have to do that. Those are actually okay, totally acceptable things because, yeah, I've added those. So once I've checked, and sometimes I will do this on a separate branch. I don't have time because we're like 5 minutes from the end here. I'll just do a dry run. But what I can do here is I can say, okay, there are no like deal-breaking conflicts here. What I just need to do is Git rebase my main branch here with origin main. And when I say Git rebase origin main, it'll tell me it has successfully rebased and updated refs head main. When I run my little Git log now, I see there's fixed path to CSS file, which was the commit that the other person, you know, Carl Prime or something like that did on the other machine. And now my other commits that I just wanted to push in the first place, they've been rewritten. Now they've got different hashes to them, which ordinarily would be a problem, but because we got the error of the branches out of sync because I wanted to push in the first place, those hadn't been shared to the public. So there's absolutely nothing in the world wrong now with saying git push origin main, and now it's going to be happy because my branch is squared with the remote. We got our work exactly in the order that we expected to be. Nothing got lost. We used git diff, and that's all I got for you. We got 5 minutes for questions. Thank you all for coming out tonight. Anybody there? Sure. No, I'm running Z Shell, and I'm a fan of a little. Actually, it started off really little, and it's gotten quite big. Called Oh My Zish. I'll pop the link here into the journal. So I like Z Shell. It's very close to Bash. If you're at home on Bash, you'll pick up Z Shell. Z Shell has some nice things with like directory globbing and stuff like that are precious to me. And then it's got the Oh My Zish program, which lets you, build all kinds of plugins and things like that. Like when I'm hacking on Ruby or something, I've got an Oh My Zish terminal that works with Ruby environment and stuff like that. Fish is underrated. I'm a Fish user. Oh, you're so welcome. Hey, Jeremy. Mm-hmm. Mm-hmm. Well, there is now because again, right, I have opted to configure Git that pulls will only work now when they can fast forward, meaning that there's no work on my remote that my local branch doesn't already know about before any of the new work I did. So the only way that it's going to work now is basically a fast forward merge. A fast forward merge is the simplest merge because it's like, here are my changes here. I need to get the ones from the remote. I pull those down, and then it basically, the fast forward means what is referenced by head, capital H-E-A-D, is the most recent commit. That's the only time I let pull work because it works gracefully. I don't lose anything, and most importantly, I don't get a merge commit. I'm anti-merge commit. I know there are other people that share a different view of that and think merge commits are great. To me, they're just noise. And particularly if you're working in a small enough team where you can afford to rebase, or if you're just working on a project yourself, then by all means rebase instead of doing that. So that's the only thing I can do with the pull. But again, pull is just a wrapper for two commands, git fetch and then git merge, which is how, when you do git pull, if you don't say fast forward only, in doing git pull, you can end up with a merge commit. And again, I don't like those things because you can end up with weird things like called foxtrot commits. Like what we just had here could have been a foxtrot commit because I've got to basically merge coming and going. I've got to merge the upstream stuff into my thing, and then I've got to remerge my feature that comes back into that. And so you basically, it looks like a dance diagram of the foxtrot, basically. That's why they call it that. Hmm. Mm-hmm. Yes. Yeah, yes, yeah. Mm-hmm. Right. 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 It depends in part on how deep in the past we're talking, and it also depends on, has that mistake been shared publicly. Once something is up on GitHub, I can give you Git filter branches. Like if you've got to go deep in the history and really make sure that, commit to commit to commit, that, SSH key or something is in there. I can give you that, how to do that. But the bigger thing to realize from a cybersecurity perspective is the second my private key is on GitHub, the solution is, yeah, we got to get that out of Git, but I've also got to generate a new private key because that key has been compromised. And so, in some ways, like cleaning up your Git history is the least of your problems at that point because, you've got a compromised key. Git filter branch is the way to do it. If you've made the mistake and you catch it before you have pushed, then you can use Git Rebase and do what I just did, where I basically got rid of that little switcheroo on those title tags. That's the best way to do it. And then, yeah. See, and here's the thing, Andrew, like I'm suspicious about any kind of package that's going to help me fix my cybersecurity problems. Like get in there, get after it yourself and figure out what's actually going on, right? I will, on your good recommendation. I'm just saying my spidey sense about what I would actually run. Yeah. And that's an argument, again, if that's a problem where you accidentally drop in ISOs or SSH keys or something like that, like those might be good file names to add to your global git ignore. Because here's the thing, when a file name is in the git ignore file, no active god or man is going to allow you to, well, I think you can actually force it there through some but in your run-of-the-mill running, git add and things like that, if a file is said to be ignored in a git ignore file in that global thing, then that's it. It's not going to be in there. So if there's a particular file name or something like that, then that would be a good thing to do. Of course, it's not easy to predict those things, especially if you've got like a per project access key or something. Other questions or thoughts or? Thank you all for coming out tonight. This is a big ask and a really big turnout for a Thursday night. It's different fundamentally. What Windows lacks, regrettably, oops. What Windows lacks is a POSIX style. What is the word I'm looking for? POSIX specification. POSIX, it has a whole bunch of other things on it. Like it goes into files, systems. Yeah, and actually Wikipedia might be our basic thing. But there are certain commands in certain locations. So you'll have directories like etc and bin and var and lib and proc and so all these different things that you see on a Linux file system. Windows is the outlier now. Now Mac OS is a really pretty, really expensive GUI over a kind of twisted around Unix kernel, but at least it's got the core POSIX kind of things to it. And that to me is something that everybody who's serious about development, serious about computing, you should know. Fine if you know Windows, but you should know POSIX style command line. You should know how to get on there and list things out, move files around, figure out where you are, modify your path, you know, set a different terminal shell, like whatever it is that you're doing on there. So yeah, the differences are bigger than that. And of course, the biggest difference of all is that Windows gave us, you know, the backslash, right? There is no such thing as a forward slash. There are only backslashes. So there's backslash and slash. But of course, Windows insists that even though the whole rest of the world uses a slash, Windows has got to use a backslash. So even things like writing paths and stuff like that gets to be a pain in the neck, which is a big problem. Mm-hmm. All right, Jeremy's promoting PowerShell, but yeah. Very good. All right, I think I'm tired. If you want to contact me, you've got my contact information. I love emails. I love talking about a Git. If there's big enough interest on campus, I would love to have like a Git enthusiasts Discord or Slack, or if some enterprising student wants to set up something like that, like count me in. I'm totally on board with that. And otherwise, just everybody, welcome to the new semester. Thank you to Dean Fortnow for putting out the announcement for this and asking me to do it. And yeah, have a great semester, and I hope to see you all around and back in person. It looks like come next week. All right. Bye for now, everyone.